Hey there, grade nines. This is going to be the first lesson of chapter 3. Basically, what we're doing is we're introducing what rational numbers are. So, rational numbers can be described as any number that you can represent using a fraction, where you have your numerator and your denominator, but your denominator cannot equal 0. All right. So, anytime that we can actually represent a number as a fraction, and both of these can be integers as well. So it could be positive or it could be negative. So that doesn't matter. But an example of a number that you would not be able to use that would be like pi, for example. Pi we cannot represent as a fraction because it's what we would call a repeating decimal. So it doesn't end, so there's no way that we can actually put it into a fraction. Same with the square root of 2. So anything that you can actually represent as a fraction, doesn't matter the size of the fraction. So we're going to go through a couple examples, but this is just something to kind of keep in mind. So our denominator cannot equal 0, but our m and our n, so the numerator and the denominator, can be any integer. All right, so positive or negative. All right, so for a couple examples that we're going to go through is we're actually going to talk about and feel free to pause the video so that you can practice this as well. So I'm going to give you some numbers, and what I want you to do is I actually want you to come up with one to three possible rational numbers that can fit in between these. So here we have 1.25 and negative 3.26, negative 0.25 and negative 0.26. Let's go to negative 1/2 and 1/4, and then negative 1/4, 1/2 and negative 1/4. All right. So feel free to pause the video. Try to find anywhere between 1 and 3 numbers that could go in between, and then when you come back, I'm going to continue. So let's go through this right now. So for this one, we have a large range. So we have positive 1.25 all the way to negative 3.26. So there's really any number of answers that you can put in. I could just say negative 2, okay, which could be represented by negative 2 over negative 2 over 1, negative 4 over whatever. So any possible number would technically work there. I will need a number that will fit in between here. Let's try to make it easy. So negative 0.255. Okay, which is technically in between 0.26 and 0.25. Okay, so that's a negative. Okay, this one we also have another wide range, so we're going from negative 1/2 all the way to positive 1/4. So I could even say negative 1/4 would be able to fit because it's smaller than 1/2, larger than 1/2 and smaller than 1/4. So in between here, I've got negative 1/2 and negative 1/4. I could say maybe negative 1/3. Okay, so all of those would actually work in this situation. All right. The next example that I'm going to actually give you guys is I'm going to give you a group of numbers, and your task is to order them from least to greatest. Okay, so if we have numbers, for example, like 1.13, and this is a combination of fractions and decimals. I'll try to make my decimals nice and big. Negative 10 over 3, negative 3.4, 2.7 repeated. Right. Let's go 3 over 7, and negative 2 and 2 over 5. All right, so feel free to pause the video and then put them in order from least to greatest. So your least would be your negative numbers. All right. When you unpause the video, we'll get going. All right. One thing that I might want to do is I want to maybe change all of them to have the same term. So maybe they could all be fractions or they could all be decimals. For me, it might be easier to change them into decimals. Right. So when I'm looking at this one, I can say this is negative 3.3 repeating. This one is going to be negative 2.4, and this one is going to be 0.4 or 2, somewhere around there. All right. Now it should be a lot easier to put them into order. So my lowest one is going to be my negative 3.4, followed by my negative 10 over 3. Next, it looks like it would be this one, so negative 2 and 2 over 5. Now I'm looking for my next smallest, which would be 3 over 7. Then I've got 1.13 and 2.7 repeating. Okay, so all of those can be represented. These are all technically rational numbers. Okay, so when you have a repeating decimal, that doesn't necessarily mean that it's not rational. A decimal or a fraction that won't terminate would be considered an irrational number. So we're working with rational numbers once again, where we've got they can be represented as a fraction, where the denominator and the numerator are both are integers, and the denominator is not equal to 0. All right. So hopefully that makes sense. If you have any questions, you can send me a hangout. Bring your questions to the Zoom chat, and make sure that you get working on your homework. Good luck.